So as you guys get your multimeters, we're just gonna talk about this really quick. So as you guys notice, there's like 3 inputs, but you only have 2 probes. So black one is always gonna be in the center. You're gonna exclusively measure current on the left side, so that's gonna be the DC 10 amp mode, which is only for the yellow, so you'll always need to switch out for that. But for everything else, your red will be plugged in onto the right side. So there's little symbols on your thing that'll tell you which mode is for what side.
And the red goes in green.
I can't emphasize that part enough, that what Winter just said. If you measure the current on the right side rather than on the left side, very likely you're going to burn out the fuse inside the multimeter. It's a 50-cent replacement, but it's just a hassle because you have to unscrew it and replace the fuse. So always measure current with the red probe on the left, voltage on the right. When you get trained and you're really good at it, you can measure it on the right side. There is a way to do it, and that's for very low currents.
Yeah.
But when you're working
Yeah, we're
with
just
a typical
getting
circuit, current's always on the left.
Yeah, it's just when we're measuring current, we're gonna do it on that side, but we're not doing that right now. Okay. Yes. So the first thing we're gonna do is just measure our batteries. So you can take your battery, have it, turn your thing to, I'll say DCV. So you can turn it to that red input right there, and then if you put the probes to the head, should get the voltage of, so that's gonna be the voltage of your battery. It's gonna be around 9 volts. So if you just put it on the 2 metal ends of your battery. It shouldn't matter which end, it just might say negative. If you flip it, it'll say positive. So once you've checked your battery, you're gonna move on to the resistors. So if you could take one of the 470 ohm resistors in your kit. You're just gonna put it across two separate rows within your breadboard.
Oh, the one we had 2.
So when we're looking at it, the blue should be at the top, just like that, right?
Yeah, it doesn't really matter too much as long as it's horizontal. Yeah, just make sure it's not in the same row of 5. So once you have the resistor in your board, you can switch. So this little thing with this Greek symbol right here, that stands for ohms. So that is the unit of measurement for resistance. So once you've measured your voltage, which is V, you can switch over to this one. Then you can check. So you just put in your 470 ohm resistor. You can check if that is the value of your resistor. So just touch the ends to the end.
I can't see what you're setting.
Yep. So it's gonna be at this one little Greek symbol. Kind of looks like an omega. Stands for ohm. Just be careful. Your multimeter will auto adjust to the units. So right now mine's on mega ohms, I think. So just make sure when you're reading your measurement, you're checking what units it is. Sometimes they'll do kilo ohms, just regular ohms. Just make sure you're looking at the correct units before you record anything. If you're done with the 470, you can plug in we're gonna be using the 1 kilo ohm resistor for the next part. You can remove it if you want. If you can also leave it on, it's not going to be too big of a problem. If you have time, we can. I'll say no. Yeah, you can just take it off. You can take it off.
And you're right about that human error, because everything is off just under. Yeah. Now, if it's over, then we know it's more than 1. You're right, they're all under.
So you can attach the leads to your battery now if you'd like. Just be careful. Just be careful not to let the ends touch if you'd like. Yeah. So we're gonna take the leads of the battery, we're gonna connect to the resistor. That's gonna make this circuit on the board that I drew earlier, so battery to circuit. So connect one end to the same column as one end of the resistor, and the other to the other.
They'll be in the same rail though, right?
Yeah, so same. So it should be in the same rows as the
Oh, you
other
want us
ends
to
of the
put it on the
resistor.
board now?
Yeah, we can put it on the board now.
But not the same row as the resistor though, correct?
Should be. Column, I should say column. It should be in the same column as the resistor.
Oh, gotcha.
Yeah.
Gotcha.
They're connected in columns, so this way the little underneath the board is going to act as a wire, basically, to connect those.
Which resistor did you want us to use? It doesn't matter.
The 1000.
It is, but it's kind of like water.
So I think most people have this circuit built, right? Okay. So now we're going to measure current. So this is the really important part. So we're going to have to move this from the right side to the left side. So this is one of those things, current. Very important that we switch to the other side. And then switch to the DC 10A mode. So that's going to be measuring your current. Current is the measure of the rate of electricity flow. So basically we need to be able to find a way to go into the wire and measure that. So what we're going to need to do is we're going to have to open the circuit you just built and basically insert that multimeter as an element. Kind of like if you, right? So current is, we can think current as like, you can think of circuits as like pipes with water. So your battery is going to be like a water tank. These wires are going to be your pipes, and the resistances are blockages in your pipes. So when you're measuring current, you're trying to measure how much water is flowing through a given point within a certain amount of time. But you need to be within that pipe in order to measure that. So the point is that we need to open that whole circuit in order to be able to measure that. So what you're going to want to do for this part, you're going to need to disconnect one leg of your resistor and one leg of your battery. So do we have clips for these? Or do they just have to hold them? Do they just have to hold them?
We took them away.
Okay.
They can hold it.
Okay. Maybe you want to work in partners.
Yeah.
So you're going to have to hold one probe to the end with the battery, and the other end to the open end of the resistor you just made. You might want a partner for this. It's a little hard. It's a little tough to balance. Right. So you just removed one end of your battery and one end of your resistor. You're basically inserting your voltmeter, your multimeter as kind of like an element in your thing.
And then what should our screen read?
Should read something very small.
0.09.
So can anyone tell me what they ended up measuring for that current?
I had a 0.009.
Point. Okay. Did everyone get this? Or about this value? Okay. So I kind of already explained to you how voltage is like water, current is like the water in the pipes, and resistances is like blockages in the pipes. So since these are all directly related, you can tell that these all have an effect on each other. If you change one of these values, it'll affect the other values. So basically, this is a law called Ohm's law. So basically, that basically says that the total voltage is going to equal to the current times the resistance. So if you guys want to calculate, so we already told you that the battery is 9 volts, and you know that your resistor is about 1,000 ohms. So if you do your calculations, that should check out. Yeah. So basically, when you have a set voltage, The higher resistance you have, that means the more blockage you have, the less current will want to flow through. The smaller resistance, the more current, and kind of vice versa. These are all very direct relationships, so yeah. Then Ohm's law is the law of stating this, so that's the formula. Of course, you can change it to all your others. Important thing about circuits, so basically, a lot of circuits, if you have high current going through any power, that means there's going to be a lot of energy flowing, a lot of potential for things to overheat. So general rule of thumb is we want to not have a very high current. So that's general rule of thumb. We kind of talked about those power where we prefer high voltages over high currents just for energy conservation. And then the water pipe analogy, I've kind of explained that. Okay, so we can combine multiple resistors. So there's two main types of connections we have, which are series and parallel. So in series, basically the resistors are going to be connected one by one, so all in a row like that. Whereas in parallel, they're going to be connected, all of the legs of the resistor are going to connect to the same points. If that makes any sense. So in the series, we basically still have one pipe that carries all of the current. You have more blockages, more resistances in the total pipe, but same pipe, same amount of water going through all of that. Parallel, we have that your big water supply, your voltage, but then you come up to that part where it splits off into multiple paths. So in parallel circuits, the current over the resistors will split off into different paths, basically. They'll rejoin at the end at that other end where they all meet back up again. So basically, continue with series circuits. It's all one wire, all one connection, no splits or junctions. So current is going to be the same through all of the units. So if we know that I is going to be same through all of the units and we have varying R, then if we measure the voltage of each individual resistor, they're going to be different. So each resistor is going to absorb a different amount of energy, basically. So the higher resistance, the more energy it's capable of absorbing. Okay. And what we can do is if we have multiple resistors, let's say, and we want to find what the total resistance of the system is, say, because you don't want to buy 10 resistors, you just want to buy one to substitute your circuit. So you can find your equivalent resistance just by adding all of your resistors, the resistance values together, and that's going to be the total resistance of the circuit. Make sense? Parallel is a little different. So I already explained that voltage is kind of a relative difference between 2 points. So as you guys kind of saw in the parallel circuit, all of the resistors right? All of the resistors were all connected at the top and at the bottom. So these are all connected at this one point by wires. We don't consider wires to be anything that interferes with this. So they're all connected at the same point. And voltage is relative, so it doesn't matter what path you take, it's just a difference between 2 points. So in parallel, all of the units are going to have the same exact voltage, but because they could have varying resistances, you're going to know that the current will be different through each. That's what we're saying with the water analogy. The current is going to split through the different pathways it has and rejoin at the very end. So this is kind of different where versus series parallel circuits, the lower resistance, the higher current is going to have. So say this is going to be like 3 pipes. One has a really high resistance, so it really doesn't want anything to go through. One has basically no resistance. So more water is going to be able to flow through the one that doesn't have any resistance versus the one that's blocking most of it. So the equivalent resistance for this is a little more complicated. It's kind of an inverse relationship. The formula is 1 over the equivalent resistance equals 1 over, kind of got messed up on this. I'll rewrite it here. All of you. So 1 over the equivalent resistance equals 1 over R1 plus 1 over R2, and so on. Are y'all good on that? Yes. Okay. Sure. Multimeters. So you guys know that when we just put the multimeter in to measure a current, we had to kind of insert it into our circuit. So we can also think of our multimeters as resistors, right? Everything has a resistance. So so multimeters, basically the reason why you can turn them on. They'll beep if you don't turn them off after a while if you want to turn those off right now. They'll turn off automatically after a while. They'll just beep you to let you know. So the reason why we have these different entryways for the multimeters is because there's different resistances. So the multimeter can adjust its internal resistance so it can measure the correct values it needs. So with current, we had to insert it into the ammeter into the circuit. So if we think of the ammeter as like a resistor, this is going to contribute some resistance, but we don't want it to act as a resistor that's going to interfere with the rest of the circuit. We don't want, that's fine. We don't want this to interfere with the rest of the circuit. So basically, these are going to have very, very, very low internal resistances when you're measuring current. So the reason is for that, because in series circuits, the high resistance absorbs more voltage. So if this is close to 0, this will absorb relatively nothing. So this will still maintain the same current. As we kind of talked about, the equivalent R1 plus 0 is still going to be R1. Does that make sense? If we're measuring the voltage across this resistor, it's going to be a little different. We're going to connect that in parallel. The reason being it's going to be a measurement of 2 points, right? So we're going to measure this voltage across this resistor. We're going to insert these 2 points, which is basically going to be a parallel connection. And so when you do that parallel connection, you don't want that to interfere with the total resistance of that circuit either. So if the resistance of that voltmeter is infinitely high, so 1 over whatever plus 1 over infinity, which is basically 0, will not affect that. So that's the main reason we have the multimeters. You need to switch those. With the very low resistance, it's very easy to burn that out, so that's why we ask you to be very careful about that. Just make sure you're always checking before you use that. That's about it.
To emphasize that point, what would happen if you put an ammeter, so instead of putting a voltmeter there, you put the current meter there?
So if we had an ammeter, so the ammeter has basically no resistance, so all of your current will want to flow through that. But because it has no resistance, it can't handle that much electricity, so that's why. So it'll blow up. There's a fuse in there, so it won't blow up in your face, it'll just stop working. But yeah. It's not really a problem if you insert a voltmeter the wrong way, just because it's such a high resistance. It's just the ammeter we need to be very careful about when we're measuring current. So the next component we're going to talk about is diodes and LEDs. So diodes are basically one-way devices. So the way we draw diodes in terms of diagrams is going to be like this triangle with this little line at the bottom of it. So that's so diodes are basically one-way devices. So they only allow current to flow through one direction. So you guys already did that with the experimental design. You saw that if you did the short leg, it wouldn't work no matter what, but if you did the long leg, it would work. So diodes only allow current to flow through one direction. If they go through the other direction, they'll block the current. LEDs are a type of diode. They stand for light emitting diode. So diodes usually emit their energy that they receive through heat. Light emitting diodes just convert that into light energy instead. One thing to know is that unlike resistors, diodes have a set voltage they will always consume. So you guys saw that when you had one battery versus two batteries. If you had one battery, it didn't always turn on. If you had two, it usually did. So there's usually a set voltage that makes the LED jump so that it works. It'll always consume that amount of power. That's why it's very careful. You need to be very careful in attaching other elements to LEDs and diodes. So basically, this project is kind of like what you did with the experiment, where you have diodes with resistors. So the important thing to know, you usually have to put diodes with resistors. So the diodes will always consume a certain amount of voltage, but they can only handle so much current before they glow. So we take the resistors in there so that they can absorb some of the extra current, reduce the total current that's available in the circuit. So that way there's less load affecting that diode, but it can still have the same voltage it needs to turn on. So basically, if you want to look through what the experiment would do, we might go through it no, probably not, okay. If you ever want to look at it, it's gonna be on page 50. So basically, it's just describing how the diodes always consume a certain amount of voltage and how we need to put resistors in series in order to absorb some of the load so these diodes don't overload. Yeah. We can continue. I think that's about it I have for today.